So there are two types of equilibrium. Okay, ma? First one is translational equilibrium, and the second one is called as rotational equilibrium. Okay, ma? Translational equilibrium as well as rotational equilibrium. So what is meant by translational equilibrium? Okay, ma? So here I will write separately. So translational equilibrium. Okay. So if net force acting on the system is zero, then such type of equilibrium is called as translational equilibrium. That's okay. System paina net force zero undi anukondi, then I can say body is in translational equilibrium. Okay, let us try to see some example. Consider this is a body of mass m. It is resting on this ground. Okay. So is this body in translational equilibrium or not? Is it translational equilibrium lo unda leda? Undi. Ela cheptaru? How can you say? Forces are definitely present. Weight of this body mg is acting downwards, no? Normal reaction is acting in upward direction, no? So n and mg, they are getting balanced with each other. Clear? No? When they are getting balanced with each other, net force is zero. Are you able to understand? Let us see one more example. See, ma. So this is a jeep. Okay. So which is traveling on a road with uniform velocity. Uniform velocity. Clear, no? Now this body, is it in translational equilibrium or not? Jeep traveling on a road with a uniform velocity. Is it in translational equilibrium or not? Unda leda? Undi. Ela cheptaru? Translational equilibrium lo unda leda? Uniform velocity means acceleration zero. If acceleration is zero, net force, mass into acceleration zero. So definitely it is in translational equilibrium only. So translational equilibrium means what? Net force acting on the system should be zero. Here there is no net force, no? If there is net force, jeep will accelerate. Net force unte bodies em chestayi? Accelerate avutayi. Jeep, is it accelerating? No. So definitely it is in translational equilibrium. Are you able to understand? Similarly, let us see, this is a rod, uniform rod, resting on two knife edges. Clear, Nama? It is resting on two knife edges. Okay. Now is it in translational equilibrium or not? Is it in translational equilibrium or not? Chapandi. How can you say? How can you say? Which forces are balanced? Weight of the body will be acting at its center of mass, no? So weight mg is balanced by which forces? A forces balance chestunnayi ikkada. This knife edge, it will give a normal reaction n1, no? Ee knife edge oka normal reaction istundi kada. Rod will apply some force on the knife. Knife edge also will give a normal reaction. Every action has an equal and opposite reaction. Clear, no? Similarly, same rod is resting on this knife edge also. Are you able to understand? It also gives a normal reaction of n2. So because rod is not moving in upward direction, it is not going in downward direction, I can say that n1 plus n2 should be balancing the weight of this rod. So n1 plus m2 is equal to mg. So therefore, what is the net force? Net force acting on the rod is zero. So definitely this is also in translational equilibrium. Are you able to understand, ma? Okay. Similarly, let us take a body rotating in a circular path with same constant uniform velocity. V tangential is equal to constant. It is moving in a circular path. Tangential speed, it is a constant. Are you able to understand? Now can you say, is the body in equilibrium or not? Translational equilibrium or not? No. How can you say? Right? ఇది కూడా మూవ్ అవుతుంది కదా, ఇది సర్కులర్. అయితే డిఫరెన్స్, వాట్ ఈస్ ద డిఫరెన్స్? ఈజ్ ఇట్ ఇన్ ట్రాన్స్లేషనల్ ఈక్విలిబ్రియం ఆర్ నాట్? నో. హౌ కెన్ యూ సే? విచ్ యాక్సిలరేషన్? Centripetal. See ma, for a body to move in a circular path, centripetal acceleration is always required, no? ఇది ఎప్పుడు ఉండాలి కదా. సో నెట్ యాక్సిలరేషన్, ఈజ్ ఇట్ జీరో? నో. ఇఫ్ నెట్ యాక్సిలరేషన్ ఈజ్ నాట్ జీరో, దెన్ నెట్ ఫోర్స్ ఈజ్ ఆల్సో ఇట్ ఈస్ నాట్ జీరో. సెంట్రిపెటల్ ఫోర్స్ ఎప్పుడు ఉండాలి కదా దీనిపైన. ఫర్ ఎనీ బాడీ టు మూవ్ ఇన్ ఎ సర్కులర్ పాత్, వాట్ ఫోర్స్ ఈస్ రిక్వైర్డ్? Centripetal force is required. Clear now? And centripetal force is present, so net force is not zero. So this body is not in translational equilibrium. Net force is not zero. Okay? So it is not in translational equilibrium. Okay, ma? This body is not present in translational equilibrium because net force is present here. Understood, no, ma? So therefore, wherever net force acting on the system is zero, then I can say that the body is in translational equilibrium. Okay, that's it. Similarly, let us see what is meant by rotational equilibrium. Okay, rotational equilibrium. Now can you say what can be rotational equilibrium? Translational equilibrium already explained, you know. Similarly, what can be rotational equilibrium? Net torque acting on the system is zero. Net torque acting on the system, if it is zero, then it is called rotational equilibrium. Net force is zero, the translational. If net torque is zero, then it is called as rotational equilibrium. Are you able to understand? Sima. So consider this is a disc. Are you able to understand? So it is rotating about this axis and disc is in rest position. It is not rotating. It means angular velocity is zero. Now is it in rotational equilibrium or not? Is it rotational equilibrium lo unda leda? Disc, it has to rotate about this axis, ma, but it is in rest position. Angular velocity is zero. Okay. Is it in rotational equilibrium or not? Definitely it is present in rotational equilibrium. Why? Because net torque acting on the system is zero. Is any force acting on this body? If no force is acting, torque also will be zero, no? Clear? If torque is zero, it is in definitely rotational equilibrium. Understood? Let us see one more example. ఇవన్నీ రాసుకుంటాను కదమ్మా, రాసుకోండి క్లియర్గా. Next, see one more case. So let us take the same disc. Are you able to understand, ma? This is the axis of rotation, and now it is rotating with an angular velocity of omega, and omega is a constant. Okay, it is rotating with same angular velocity. Are you able to understand? Angular velocity is a constant. Now can you say, is it in translational equilibrium or not? Rotational equilibrium or not? Rotational equilibrium, how can you say? Very good, that's it. See ma, omega is a constant, no? Angular velocity is a constant. If velocity is a constant, acceleration will be zero, no? Velocity constant undi ante meaning emi? Acceleration is zero. Which acceleration? Alpha. Angular acceleration is zero because alpha is d omega divided by dt, no ma? Alpha value is how much? D omega by dt. Change in omega, is it present? No, because omega is not changing. So therefore 0 divided by dt will be 0. So therefore alpha value is how much? 0. Okay. What linear force, what force will do? Force will accelerate a body. Torque will produce angular acceleration. But angular acceleration is how much? 0. It means net torque acting on this body is also 0 because net torque is I into alpha. That's all. This is the Newton's second law analogy, no ma? F is equal to ma, Newton's first law, Newton's second law in straight line motion. Torque is equals to I into alpha, same Newton's second law in rotational motion. గుర్తుంటా ఉన్నాయా? వినటం లేదు సరిగా. Okay. So therefore if alpha is 0, net torque also will be 0. Are you able to understand? Let us see one more example. Okay. See ma. So consider this is a rod which is present on two knife edges, resting on two knife edges. Are you able to understand, ma? Okay. Now can you say this body is in rotational equilibrium or not? Already we studied it is in translational equilibrium. No? Now is it present in rotational equilibrium or not? Rotational equilibrium antune meer em adagali first ఏ యాక్సిస్ ఓ చెప్పండి సార్ అని అడగాలి, అంతే కదా. You can take any axis. For example, you take this axis. About this point, is the rod rotating? Rotate అవుతుందా లేదా? No. So therefore what you can say, net torque is 0. So therefore definitely this body is in rotational equilibrium. Are you able to understand, ma? If you take axis about this point, ఈ పాయింట్ చుట్టూ ఏమన్నా తిరుగుతుందా రాడ్? లేదు. So about this point also, net torque is 0, body is in rotational equilibrium. Clear? Same rod, is it rotating about this point? అవుతా ఉందా లేదా? రొటేట్ అవుతా ఉందా లేదా? ఏందో ఐఏఎస్ క్వశ్చన్ అడిగినట్టు ఫేస్ పెడతారేంది? ఈజ్ దిస్ రాడ్ రొటేటింగ్ అబౌట్ దిస్ పాయింట్ ఆర్ నాట్? నో. If it is not rotating, net torque is how much? 0. So body definitely it is in rotational equilibrium. Are you able to understand, ma? See, ma, in this type of conditions, you can take axis about any point. That is your wish. ఏ పాయింట్ చుట్టూ తీసుకున్నా ఇది రొటేట్ అవ్వటం లేదు. సో rotation about any axis is 0. So for calculation purpose, for your simplicity, you can take any body to be your point of rotation for calculating torque. Are you able to understand, ma? So what is the note point here which we have to remember? So in this type of conditions, clear, ma? What can I say? Torque can be calculated. Torque can be calculated about any axis of rotation. About any axis of rotation. Are you able to understand, me? You can take any axis and around that axis you can calculate the torque due to different forces. Understood? No? So this is what is called as translational equilibrium and rotational equilibrium. So translational equilibrium means net force acting on the system should be 0, and rotational equilibrium means net torque acting on the system should be 0. That's it. Fine. So let us see this problem. So uniform rod of mass m and length L is suspended through two vertical strings of equal lengths fixed at ends. So a small object of mass 2m is placed at a distance of L by 4 from the left end. Then find the tensions in the two strings. Clear? Let us try to draw a diagram of this one. Okay, ma? So this is a rod. What is the length of the rod? Length of the rod is L, mass of the rod is m. Clear, ma? So it is suspended by two strings, and what are the lengths of the strings? Length of the strings are equal. Clear, no? So it is suspended like this, and they are attached at the ends of this rod. Okay, mass of the rod is m, length of the rod is L, and what is the mass? Mass is m already given. Okay, then small m, let us write. Then what is happening? A small object of mass of 2m, it is placed at a distance L by 4. L by 4 means where? Let us take somewhere here. Okay, ma? So this distance I can call it as L by 4. Okay. At that distance we are placing one point mass. Are you able to understand, ma? So what is this total distance? This total distance is L by 4. And what is the mass of this point mass which is present? Mass is 2m. Then you are supposed to find out if tension in the first string is T1, tension in the second string is T2, T1 comma T2 values you are supposed to calculate. That's it. Understood my question? Now can you say how can I do this calculation? Rod suspended by two strings, mass of the rod is m, okay, ma? And there is a mass of 2m at a distance of L by 4. See, ma, first of all, this total rod, it is in translational equilibrium. Rod translational equilibrium lo unda leda? Undi kada? Net force, is it acting on the rod? Rod is in rest position. No? Rest position means net force acting on the rod is 0. So therefore I can say first point is, so if you solve according to translational equilibrium, okay, ma? So what are the different forces which are acting on this rod, ma? See ma, its own weight, small mg will be acting downwards, no? Weight of the own rod. Rod weight ekkada untundi? Where will be the weight of the rod? At its center of mass. At its center of mass. So weight mg will be acting downwards. Then at a distance of L by 4, we are placing one more mass, no? And what is the weight of that mass? Weight of that mass is 2 mg. Mass is 2m, weight is 2 mg. So these are the two forces which are pulling the system in downwards direction. Clear, no? Then how it is in balanced condition? Tensions are acting in upward direction, no? Tension T1 and tension T2, they are acting in upward direction. So for rod to be in translational equilibrium, net force should be 0, no? Net force should be in 0. So all the upward forces will be balanced by downward forces. So I can say T1 plus T2 is equals to 2 mg plus mg, which is equal to 3 mg. Can I write like this? Upward forces evi ikkada T1 T2. Downward forces 2 mg mg. They are balancing, no? So therefore this is my first equation. Are you able to understand, no? So I want T1 and T2 both of them, no? Two unknown quantities are there. It means definitely I require one more equation. So second equation from where can I get? Inkoka equation ekkada nunchi vastadi? Second, one equation I calculated from translational equilibrium. Are you able to understand me? Second equation from where can I get? Second equation ekkada nunchi vastadi? This rod is present in rotational equilibrium also, no? Rotate avutunda emanna? Ledu. It is not rotating, no? It means definitely it is in rotational equilibrium. Rotational equilibrium about which axis? Any axis. If you take this axis, this point, any point you take, always it is in rotational equilibrium. Are you able to understand? So therefore, take the equation of rotational equilibrium. Okay. What is meant by rotational equilibrium? Net torque acting on the system should be 0. Are you able to understand, ma? Okay. Now can you say, I will take axis of rotation to be which point? A point తీసుకుందాం చెప్పండి. So here how many points are there? Let us take this is first point, let us take this is second point, let us take this is third point, and let us take this is a fourth point. Okay. So it is better to take axis of rotation about which point? A తీసుకుంటే బాగుంటుంది. About first point. Okay. Okay. Let us try about first point. Are you able to understand, ma? So taking point number 1 to be the axis of rotation. Okay, ma? Taking point number 1 to be my axis of rotation. Okay. So about point number 1, net torque should be how much, ma? Net torque should be 0. Okay. Now totally how many forces are acting on the system, ma? How many forces are acting on the system? చెప్పండి, ఫాస్ట్గా ఉండాలి. ఏందా కప్పను మింగిన పాము మాదిరి ఉంటే ఎట్లా? మీరు కప్పను మింగిన పాము చూసినారా? పాము ఎంతుంటే ఇంత పెద్ద కప్పను మింగుతుంది అనమాట. ఇంకా అట్లే పడుకొని ఉంటుంది. అట్లా ఉన్నారు మీరు. చెప్పండి ఫాస్ట్గా. How many forces are acting? 1, 2, 3, 4. 4 forces are acting. Are you able to understand, ma? So calculate torque because of all the forces and add all of them. Total should be how much? Total should be 0 because net torque is 0. అర్థమవుతుంది కదా? Now see. So first calculate torque due to T1, this force. Okay. And I am taking axis here only, no? Where I am taking axis? I am taking axis to be point number 1. Okay. And force is directly acting on point number 1 only, no? Force ekkada act avutundi? Axis paina act avutundi. Force is acting on the axis itself. Then can such a force, can it produce torque? In last class what we studied, if a force is directly, last class absent కదా, డబ్బా రేకుల్లో డబ్బాలు కొట్టినట్టు ఉంటుంది. అందుకే absent అవ్వకూడదు. అర్థమవుతుంది కదా? So if force is directly acting on the axis, it cannot produce any torque. Already we studied, no? So torque due to T1 is how much? 0. Understood, Nama? Next force let us take. Torque due to 2 mg is how much? Very good. So from the axis of rotation, what is the perpendicular distance, ma? Already given, no? Perpendicular distance is L by 4. That's all. So torque formula R into F. So radius is how much? Radius is L by 4. Force is how much? 2 mg. Are you able to understand? Ma? So torque due to 2 mg is this much, L by 4 into 2 mg. Now the question is it positive torque or negative torque? అది కూడా చూడాలి కదా. Torque due to 2 mg, is it positive torque or negative torque? Negative torque. How can you say? So R dash cross F dash. వినాలి చాలా కేర్ఫుల్గా వినాలి. R dash cross F dash. Thumb is inside the board, no? So definitely negative torque. Or you can say this force, if it is only this force is present, then this force will make the rod to rotate in clockwise direction, no? ఈ ఫోర్స్ ఏం చేస్తుంది చెప్పండి, రాడ్ని ఎలా రొటేట్ చేయాలని ప్రయత్నం చేస్తూ ఉంది. ఇట్ ఈస్ ట్రైంగ్ టు రొటేట్ ద రాడ్ ఇన్ క్లాక్ వైజ్ డైరెక్షన్. క్లాక్ వైజ్ డైరెక్షన్ మీన్స్ నెగటివ్ టార్క్. సో మైనస్ L by 4 into 2 mg. Understood? Similarly, torque due to mg is how much? Next, this force. Torque due to mg. చెప్పండి, what is the distance from the axis of rotation? L by 2. Clear nama? So L by 2 multiplied by what is the force? Force is mg. Now is it positive torque or negative torque? Definitely negative torque. This is also producing clockwise rotation, no? So negative torque. Minus L by 2 into mg. Understood nama? Next, torque due to third force. So torque due to T2 is how much? So from the axis, what is the total distance? From the axis, total distance is L. Clear, no? So L into, now what is this force? This force is a T2. Now this is producing positive torque or negative torque? Positive torque, because this force will make the rod to rotate in anti-clockwise direction. Clear, nama? So plus L into T by 2. Now add all of them. So therefore net force is how much, ma? Net force should be 0, because rod is in equilibrium. Okay, so add all of them. So 0 plus, what is the torque due to 2 mg? So minus, I will write, minus L by 4 into 2 mg plus torque due to mg is how much? It is also minus. So minus L by 2 into mg plus L into T2. Okay, ma? So this is the total net torque. So this is my second equation. Understood now? So from translational equilibrium, I got one equation. Are you able to understand, ma? From translational equilibrium, I got one equation. Here, how many unknown quantities are there? 2 unknown quantities are there. And from rotational equilibrium, I got one more equation. Here also I have T2, no? So take this T2, substitute here. Then I will get T1. No? That's all. That is my answer. Clear? Now come on to the calculation. సో ఎవరి హెల్ప్ తీసుకున్నాం ఇక్కడ చెప్పండి. ట్రాన్స్లేషనల్ ఈక్విలిబ్రియం హెల్ప్ కూడా తీసుకున్నాము, రొటేషనల్ ఈక్విలిబ్రియం హెల్ప్ కూడా తీసుకున్నాము. అంతే కదా? దట్స్ ఇట్. ఎంత వచ్చిందిరా? T1 ఎంత వచ్చింది చెప్పు. T1 2 mg, T2 దట్స్ ఇట్. అంతే ఆన్సర్స్. ఇలా ఈక్విలిబ్రియం ప్రాబ్లమ్స్ ఇలా చేయాలి. ఓకేమా? సో ఇటువంటి ప్రాబ్లమ్స్ మీరు ఇస్తూనే ఫస్ట్ ఏం చేయాలి, ఇవి ట్రాన్స్లేషనల్లో ఉన్నాయా రొటేషనల్లో ఉన్నాయా చెక్ చేసుకోండి. క్లియర్మా? చెక్ చేసుకొని ఒక్కోసారి ఒక ఈక్వేషన్ ఉంటే మీకు ఆన్సర్ వస్తుంది, రాకపోతే సెకండ్ ఈక్విలిబ్రియం కూడా తీసుకోండి. దీన్ని ట్రాన్స్లేషనల్ ఈక్విలిబ్రియం తీసుకోకుండా కూడా చేయొచ్చు. ఎలా చేయొచ్చు? ఇప్పుడు మనము ఫస్ట్ పాయింట్ దగ్గర యాక్సిస్ తీసుకున్నాం కదా, ఒక ఈక్వేషన్ వచ్చింది. సెకండ్ పాయింట్ దగ్గర ఇంకొక ఈక్వేషన్ రాసుకుంటే సెకండ్ ఈక్వేషన్ వస్తుంది కదా, ఆ రెండింటిని సాల్వ్ చేసిన ఆన్సర్ వస్తుంది. అర్థమవుతుంది కదా? కాకపోతే కొంచెం కష్టం. అదే ట్రాన్స్లేషన్ అయితే చాలా ఈజీ కదా, జస్ట్ ఫోర్సెస్ని బ్యాలెన్స్ చేస్తే చాలు, ట్రాన్స్లేషన్ వస్తుంది మనకు. ఓకేనా? ఎంతరా టైము? 9:09. ఓకే, యాడ్ చేయండి మరి. ఏంది ఇది రన్ అవుతానే ఉందా ఇది మాత్రం. ఓకేమా. సో let us do the calculation. So what I got there, so minus L by 4 into 2mg minus L by 2 into mg plus L into T2 is equal to 0. So L I can cancel, 2z. So therefore minus mg by 2 minus mg by 2 plus T2 is equal to 0. So T2 is equal to mg. Okay, ma? Now here I have this equation, no, from first equation, T1 plus T2 is equal to 3 mg. So take this T2 and substitute here. So T1 plus mg is equal to 3 mg. So therefore T1 value is 2 mg. That is my answer. Clear now? That is how we can do the calculation. So this is a ladder. Length of the ladder is L, and what is the weight of the ladder? Weight of the ladder is W. Clear now? So on this ladder, a man is also standing, and where the man is standing at a distance of L by 3, man is standing, and weight of the man is 3W. Clear now? And there is a friction between ladder and the ground. There is friction between ladder and the ground. Clear now? But there is no friction between ladder and the vertical surface. This wall, vertical wall will be there, no? Vertical wall is smooth. Here it means coefficient of friction is how much? It is 0, but here coefficient of friction is not 0. Understood now? Here. Then these are the values which you are supposed to find out. Find the normal reaction and force on the ladder at its base. Find the minimum coefficient of static friction needed to prevent slipping at the base. Understood now? Okay, now let us see. First of all, let us study about ladder is in rest position. No? Ladder is in rest position. It means it is in translational equilibrium. Okay, ma? Ladder is in which kind of equilibrium? It is in translational equilibrium, because this ladder, it is not slipping. It is in rest position. Okay. Now let us see how many forces are present along x-axis. Along x-axis, how many forces are present? Okay. See how many forces are present, ma? See here, ladder will be pushing this wall, no? Ladder will be pushing the wall. Then what wall will do? Wall will give a normal reaction. Clear, no, ma? So let us call that normal reaction to be N1, N2, anything. Clear, no, ma? How I got this normal reaction? Because ladder will be pushing the wall. Wall will give a normal reaction. Ante kada? Clear, no, ma? Similarly, because of this force, ladder will try to slide. No? Because of this force and some another forces also, weight of this ladder also, man of this ladder also, ladder will try to slip. Slip avalani chustundi kada. If ladder tries to slip, friction will act in which direction? Friction will act in opposite direction. FL will act in opposite direction. So consider ladder is ready to slip. Therefore, what is the friction which is acting? Friction is acting is FL, limiting friction. Okay, ma? Still, are there any other forces, ma, along x-axis? X-axis pe inka emana forces unnayemo chudandi. Okay. Ladder will push the wall, vertical wall. Wall will push the ladder. End. Are you able to understand? Similarly, this ladder will try to slip. Friction will act in opposite direction. It means friction is preventing the ladder to slip. Ladder slip avakunda friction pattukonundi da. Clear na? So along x-axis, how many forces are there? Only 2 forces are present, and they must be balanced. No? They must be balanced. Balance avakapothe. If they are not balanced, ladder will slip. Okay. So this is the force which is pushing the ladder, and this is the force which is pulling the ladder. Both the forces must be balanced along x-axis. Arthamatunda? We are studying which concept? Translational equilibrium. So therefore, what I will write? I will write N2 and FL, they are equal. This is my first statement. Okay. Similarly, let us see what are the forces which are acting along y-axis. Along y-axis, what are the different forces which are acting? Now can you see? Along y-axis, what are the forces which are acting? Come on. So first, weight of the ladder will be there, no? Weight of the ladder will be acting at its center of mass. Are you able to understand, ma? or shall I draw a separate diagram? Okay, we will write here only. Clear now? So therefore, weight of the ladder will be acting exactly at its center of mass, no? And what is the weight of the ladder given? W. Are you able to understand? So W. Still, weight of the man is also acting, no? Weight of the man is how much? 3W. It is also given, no? So weight is also acting in downward direction. Still, adeka subbaka gravitational force ante. He did not give mass here, directly he gave weight. If he gave mass, you multiply with the G value and you get weight. But he gave already weight now, you need not multiply with the G value. Understood, no? Weight of the ladder in downwards direction, weight of the man also in downwards direction. Still any other forces? Sima, this ladder will be pushing the ground, no? Then what ground will do? Ground also will give a normal reaction. And that normal reaction I will call it as N1. Are you able to understand? Still any other forces are there in Y direction? Only 3 forces are present. Are you able to understand now? So therefore, I can say which forces are balancing which forces? N1 is balancing 3W plus W, which is equal to 4W. So therefore, N1 is equals to 4W. One answer already I got. Are you able to understand now? One reaction already I got. N1 is equal to 4W. Are you able to understand? Okay. So normal and friction acting on the ladder at the base. So normal I have calculated. One value I have calculated now. So normal reaction acting at the base of the ladder is how much? 4W. Okay. Now I want to calculate FL. This also he is asking now, friction which is acting at the base. Okay. N2 is also unknown quantity. Normal reaction given by the vertical wall, that is also unknown quantity. No? Limiting friction is also unknown quantity. 2 unknown quantities are there. Arrange cheyali. I require one more equation. Are you able to understand? Ma? So this angle I forgot you to give. Ma. This angle is 53 degrees. Angle made by the ladder is 53 degrees only, I think. 53 degrees. Are you able to understand? So therefore now what can I do? Huh? Evarni split cheyali. Enduku? Now I have 2 unknown quantities, but I have only one equation. Now what I have to do? Cheste emautundi? Already we discussed now. Take now rotational equilibrium equations. Rotational equilibrium. Ladder is it rotating, ma? Ladder garran tiruta unda? So it means it is in which equilibrium? Rotational equilibrium. So write one equation for rotational equilibrium, then you will get second equation. Solve first equation, second equation. That is my answer. That's it. Okay. Now the question is, which axis shall I take? So how many points are there? Sima, I will draw this diagram here. So if this is the ladder, how many forces are acting? So one force is acting here, which is called as N1. Okay, ma? One force is FL. And here, which is the force which is acting, here it is 3W. And at the middle, which is the force which is acting, this is W. Clear, na, ma? And one more force which is acting is N2. Okay, ma? So this is what we were doing now. Bhaskar. Okay. So taking torque equation about point A. So this is point A. So if I take torque equation here, okay, then torque due to N1 and torque due to FL, they will become 0. No? Why? Enduku? Because if I am taking this point to be my axis of rotation, then N1 is also directly acting on the axis, no? FL is also directly acting on the axis itself. So already we discussed that when force is acting directly on the axis, then torque due to that force will be 0. So torque due to N1, torque due to FL, both are 0. So therefore at point A, how many forces are giving torque? Only 3W, W and N2, only these 3 forces they are giving the torque. Are you able to understand? Okay. Now let us calculate each of them and we will equate to 0. Then let us see if we can get the required answer or not. Okay. So first of all we will calculate torque due to 3W. Clear, ma? 3W. So this is the axis of rotation. Are you able to understand, ma? And what is the perpendicular distance from the axis of rotation to this force? 3W is a kind of force only, no? Perpendicular distance is this much. Are you able to understand? So how can I calculate this distance, ma? This distance where man is standing, it is already given as L/3, no? Okay. So from the axis of rotation, man is standing at what distance? L/3. At what angle? At an angle of 53 degrees. So split that L/3 into two components. Are you able to understand, ma? So this is angle 53 degrees. So this is L/3 cos 53 and this is L/3 sin 53. Are you able to understand, ma? So where this 3W is acting like this. So which is the perpendicular distance, ma? L/3 cos 53 or L/3 sin 53? L/3 cos 53 is the perpendicular distance. So therefore torque due to 3W is equal to R into F. Radius vector is L/3 cos 53 and force is nothing but 3W. Clear, no? So L/3, okay, we will substitute afterwards. Okay. Then let us go to torque due to W. Okay, ma? So W, weight of the ladder will be acting at which position? Exactly at the center of mass, no? So this total distance will be how much? This total distance will be, total distance is L, no? So this distance will be L/2. So split that L/2 again into two components. Clear, no? Angle is again 53 only, no? So L/2 cos 53 and this is L/2 sin 53. Okay. Now where W is acting somewhere here. Okay. So therefore which is the perpendicular distance once again? L/2 cos 53. So therefore torque due to W is how much? R into F. So radius vector is how much, ma? L/2 cos 53 multiplied by force is nothing but weight of the ladder W. Clear, no? Similarly we will calculate a torque due to N2. Are you able to understand, ma? N2 also can provide a torque at point A, no? This is also responsible for rotation. Clear, no? But this N2 is acting at what distance from the axis of rotation? Total distance is L. But we want only perpendicular distance, no? So again take this total L, split this one into two components. So angle is how much? Angle is 53 degrees. So this is L cos 53 and this is L sin 53. Clear, no? But where N2 is acting somewhere here, no? Clear, no? N2 is acting here. So which is the perpendicular distance? L cos 53, L sin 53. L sin 53 is the perpendicular distance from the axis of rotation. Are you able to understand, ma? So therefore torque due to N2 is equals to again R into F. Radius vector is L sin 53 multiplied by force is N2. Clear, no? Now first torque, second torque and third torque. Add all of them, total should be how much? Total should be 0. Now see if you get total value to be 0 or not. Okay, ma? Shall I rub this one? Which one is positive torque and which one is negative torque, no, ma? So torque due to 3W, positive torque or negative torque? So this is responsible for clockwise rotation, no, ma? Student ikkada ee force em chestundi responsible for clockwise rotation. Clockwise rotation means definitely this should be negative torque. Clear, no? Torque due to W, this also clockwise rotation. So again negative torque. Clear, no, ma? Then torque due to N2. See about this axis how this N2 will rotate this rod. It will rotate in anti-clockwise direction. So this torque is positive. Clear, no? So add all the torques. So therefore, adding all the torques. So minus L/3 cos 53 multiplied by 3W minus L/2 cos 53 into W plus L sin 53 multiplied by N2. Total should be how much, ma? Total should be 0. Clear, no? So shall I rub this one? Now do the calculation here. So here also I have divided by 5, divided by 5, divided by 5. So divided by 5 I will remove. Similarly L is also common, no? L also you can remove. So in the numerator, what I am left with? I am left with minus 3 by 3. 3 by 3 into 3w minus L got cancelled, no? So 1 by 2 into, in cos 53 again 3 got cancelled, 5 got cancelled, we have 3 into w plus L is already cancelled, 5 is cancelled, 4 into n2 is equal to 0. That's all, no? So therefore minus 3w minus 3 by 2w plus 4n2 is equal to 0. Clear, no? So therefore 3 2s are how much? 6. 6 minus 6 minus 3 minus 9w by 2 is equal to minus 4n2. So therefore n2 value is how much? 9w divided by 8. So that is my answer. Understood, no? n2 value we have calculated 9w divided by 8. That is my answer. Okay, come on, make note. So the second question which he is asking is minimum coefficient of friction for the ladder not to slip. Clear, no? So this relation already we have written, no? So if you see translational equilibrium, so FL should have been balancing by N2. So FL and N2 they are equal. So substitute. Clear, no? So therefore FL is equal to N2. So FL is equal to, what is N2 value? N2 value is 9w divided by 8. So minimum coefficient means limiting friction should have been already maximum, no? That is called minimum coefficient of friction. So coefficient of friction, if it is minimum, it means ladder is ready to slip. Okay, ma? Ladder is ready to slip means what? Friction has already reached the maximum value. That is why instead of friction I have written FL here, maximum limiting friction. Understood, no? And what is the equation of FL? Mu s into n. Here what is the normal reaction? Normal reaction is n1. So mu s into n1 is equals to 9w divided by 8. So because of n1 only this friction is developing, no? Clear? Now limiting friction depends on what? It depends on normal reaction. What is the normal reaction at this position? n1. And n1 value already I have calculated, no? 4w. So substitute. So mu s into n1 value is 4w is equals to 9w divided by 8. So w if you get cancelled. So mu s value is how much? 9 divided by 8 4s are 32. So that is my answer. Understood, no? సో లేట్ వస్తే ఆ బయట డోర్ వేసేస్తామా, నేను ఎక్కువ మాట్లాడితే కింది డోర్ వేసేస్తాం. లేట్ వస్తే అట్లా వెళ్ళిపోండి, ఇంకా రావాల్సిన అవసరం లేదు. ఓకే, mass 1 kg moves translationally with acceleration. So what is the acceleration in the rod? A is equal to 2 meter per second square, and it is not rotating, it is moving translationally. For example, if this is the rod, it is moving like this. Ade kada translational motion ante moving in a straight line. Rotation is not present. So these are the two forces F1 and F2 which are given. The distance between the points at which these forces are applied is equal to D is equal to 20 centimeter. Are you able to understand, ma? It means the distance between these two forces is 20 centimeter. So besides, it is known that F2 is equal to 5 Newton, which is F2, this one. This force is equal to 5 Newton. Then find the length of the rod. Are you able to understand? So write equation for translational motion. Translational motion. Okay, ma? So in translational motion, we just study about net force only. No? In rotational motion, we study about net torque. But in translational motion, we study about net force. Clear, no? Rod is translating with acceleration. It means definitely rod is not in translational equilibrium. No? Is it in translational equilibrium? No. Because acceleration is present. If acceleration is present, net force also will be present. So therefore acceleration, if I consider in this direction, then F2 should have been greater than F1. So therefore what I can write? So therefore I can write net force is nothing but F2 minus F1. Clear, ma? See, ma, here F1 cannot be greater than F2. Direction of acceleration he did not give. Direction acceleration vadem ivaladu. Nenu anukuntavanu ee vaipu pedutundi. How did I assume that rod is moving in this direction? Why can't I say rod is moving in opposite direction? No, question is, this acceleration direction he did not give. I have assumed that body is moving in this direction. How did I assume? Why can't I say acceleration is in this direction? Point is that if you consider this is the center of the rod, if F1 is greater, then F1 will produce more torque when compared to F2. So the force which is at a large distance from the axis of rotation, if I consider this one to be my axis of rotation, center of the rod, clear no? Then F1 is present at a large distance. No? So F1 will produce more torque when compared to F2. So automatically rod will rotate. But rod is it rotating? No. It means definitely F2 is greater than F1. So the torques are getting cancelled with each other. One is producing anti-clockwise torque, another force is producing anti-clockwise torque. So clockwise, anti-clockwise, they should get cancelled with each other. It is possible only when F2 should be greater than F1. So that is why I have taken acceleration to be in this direction. అర్థమవుతుంది యాక్సిలరేషన్ ఈ వైపు ఎందుకు తీసుకుంటాం? If F1 is greater, F1 is already greater, distance is already greater, no? It will produce more torque. So rod will start rotation. But rod is not rotating. It means F2 is greater than F1. Understood, no? That's it. So F2 minus F1 produces net force, and net force is equal to mass into acceleration. Clear, Nama? So F2 is how much? 5 Newton. F1 is how much? I don't know. Mass of the rod is how much? 1 kg. Acceleration is 2. So therefore, what is F2 value? F2 value is 5 minus 2. It is equal to 3 Newton. So one force I have calculated by using which equation? Equation of translational motion. Okay, ma? Sorry, F1. F1 value is how much? F1 value is F1 I think. Sorry. This is F1, not F2. F1 value is how much? 3 Newton. So by using which method we have calculated? By using the statement of translational motion. Net force always produces acceleration. Understood, no? Okay. Now, rod is not rotating, no? It means it is present in which equilibrium? It is present in rotational equilibrium. Are you able to understand? Rotational equilibrium means what? Net torque acting on the system is 0. How many forces are present? 2 forces are present. What are they? F1 is also present, F2 is present. One more force is there. Weight of the rod is also there. No? Are you able to understand? So, F1 is present, F2 is present, weight is also present. But I am taking axis to be here. No? You can take axis anywhere. మీరు ఎక్కడైనా తీసుకోవచ్చు axis. నేను ఇక్కడ తీసుకున్నాను. Are you able to understand? So, but weight is acting where? Weight is acting on the axis itself. Because weight acts on the center of mass. No? So, weight cannot produce any torque. Are you able to understand? Weight ekkada act avutundi? Center of mass. Axis also at center of mass only. So, weight cannot produce any torque. Okay, ma? So, let us call this point as point O. Okay. So, taking axis at point O. Okay, ma? Therefore, what I can say, net torque will be 0. So, therefore, torque due to F1 plus torque due to F2, total should be how much? Total should be 0. Understood, ma? Now, what is this distance, ma? This distance, I know it is 20 centimeter. But what is this distance? This distance, let us call it as x, ma. Can I call this distance as 20 plus x? I can call 20 plus x. Similarly, F2 is acting at a distance of x only. So substitute. So torque due to F1 will produce positive torque or negative torque? F1 responsible for anti-clockwise rotation, no? It will produce positive torque. So therefore, I will write minus F1 into, and what is the distance? 20 plus x. Okay, ma? Plus a torque due to F2. Torque due to F2 will produce negative torque only, no? Sorry, this is anti-clockwise, no? Positive torque. This is clockwise, negative torque. So minus of F2 into x, total should be how much? Total should be 0. F1 and F2 values already we know, no? If you know F1 F2 values, x is the only unknown quantity. So derive x value, that is my answer. Understood, no? So what is F1? F1 is 3. 3 into 20 plus x minus F2 value is 5. 5x is equal to 0. Clear, no? So 60 plus 3x minus 5x is equal to 0. So 2x is equal to 60. So x is equals to 30. Okay, ma? So therefore, total length of the rod is how much? Total length of the rod is 50 plus 50, which is equals to 1 meter. That is my answer. Okay. So this distance is 20, no ma? X value is 30. So 20 plus 30, 50. So half of the rod is 50. Remaining half will be another 50. So 50 plus 50, 1 meter is the length of the rod. Weight of the door is how much? W. So this door is held in air by 2 hinges. So this is hinge number 1 and this is hinge number 2. Okay, ma? Total length of the door is 4L, width of the door is L, and hinges are present at L and L from the edges of the door. That is the arrangement of these hinges. Okay. Then what he is asking, if each hinge gives equal force, then find the forces by each of the hinges. That is the question. Now let us see. This door, definitely it is in translational equilibrium, no? Yes or no? So, it is in translational equilibrium. Door is not moving, no ma? Door will be at same position. It is not moving. So therefore I can say net force acting on this door should be 0. So weight of the door is W, no? Where weight will be acting, ma? Weight will be acting exactly at its geometrical center. Okay. So with the help of this weight, door is trying to come down. But why door is not coming down? Door galle untunda, bhoom paina untunda. Door will be in air only, no? So with the help of its weight, it is trying to come down. But why it is not coming down? Because hinges will be opposing the weight of this door. That's all. How many hinges are there? 2 hinges are there. So let us consider one hinge will give a force of F1 and one hinge will give a force of F2. Clear, no? If weight is acting in one direction, hinges should give force in opposite direction. And he said that forces applied by each hinge is same. So therefore, can I say that F1 is equal to F2? Definitely both of them, they should be equal number. Weight is acting in downwards direction, hinges should give force in opposite direction. So therefore, I can say W is equals to weight of the door is nothing but F1 plus F2, or I can write it is either 2F1 or I can say either it is 2F2. That's all, no? Because F1 F2 they are equal, no? So therefore, I can say F1 is equals to W by 2. Also, I can say F2 is equals to W by 2. F1 is also W by 2, F2 is also W by 2 because forces are equal. Okay. Now, is this my answer? This is not my answer. Why? Why? Because weight of the door will be trying to rotate this door also, no? About any hinge. Okay. For example, if I take this hinge to be my axis of rotation, this weight W, it has a perpendicular distance from the axis of rotation. No? What is the perpendicular distance? L by 2. Okay. From the axis of rotation, what is the perpendicular distance? L by 2. So therefore, what is the torque? L by 2 multiplied by W. So torque is present. So with the help of that torque, door will try to rotate. Rotate avvadaniki try chestundi kada. If door tries to rotate, there should be some opposite torque which should oppose this rotation. And who will give that opposite torque? Again hinges only. Are you able to understand? Now let us do one thing. So let us draw the door once again. Clear, no? So this is the door. Okay. So here there is hinge number 1 and here there is hinge number 2. Okay. Weight of the door is acting somewhere here. So this is the weight of the door, and perpendicular distance from the axis of rotation is how much? L by 2. Are you able to understand, ma? So therefore, torque given by door is how much? Which one shall I take to be my axis of rotation? First of all, let us take this one to be my axis of rotation. Are you able to understand, ma? This one I will consider to be my axis of rotation. Okay. So torque about this axis is how much? Torque due to door is how much? R into F. Torque for R into F only, no? Torque given by which door I am, which force I am taking here? Torque given by door. About which axis? About this axis of rotation. From this axis, perpendicular distance is L by 2. Force is nothing but W. So positive torque or negative torque? clockwise rotation, so definitely this is negative torque. Okay, but door, is it rotating? No? Door rotate avutunda? No. It means somebody is giving another opposite torque. No? Some force is giving positive torque. Who is that force who is giving the positive torque? So that total torque will become 0. Second hinge. Second hinge will give positive torque. So that total torque will become 0. Are you able to understand? Okay. Now this is the axis of rotation. No? What is the distance between two hinges? Distance between two hinges is how much? Total 4L, nama? L. Then remaining distance will be 2L. So this distance is 2L. Understood? No? Now can you say this hinge should give force in which direction so that torque because of the door will get cancelled? In this direction. In this direction. So R dash cross F dash. Correct one. This is outside the board, no? Positive torque. Are you able to understand, ma? Door is giving negative torque. About which point? About this axis of rotation. Or you can take this one also. I am taking this one. Okay, ma? Then the second hinge should give which torque? Positive torque. It means it should produce anti-clockwise rotation. Positive torque means which rotation? Anti-clockwise rotation. About which axis? About the selected axis. So therefore, this hinge should give force in this direction. Let us call it as F3. Okay. Now see, about this axis, this hinge will try to rotate door in which direction? Anti-clockwise direction. Correct only? ఈ యాక్సిస్ చుట్టూ ఈ ఫోర్స్ ఏ డైరెక్షన్లో రొటేట్ చేసే ప్రయత్నం చేస్తుంది డోర్ని? యాంటీ క్లాక్వైజ్. ఇట్ మీన్స్ ఇట్ ఈస్ పాజిటివ్ టార్క్. సో దేర్ ఫోర్ టార్క్ గివెన్ బై ద హింజ్, విచ్ హింజ్? సెకండ్ హింజ్. దిస్ ఇస్ సెకండ్ హింజ్. ఈస్ హౌ మచ్ మా? అగైన్ ఇట్ ఈస్ R into F. So radius vector, what is the perpendicular distance from the axis? 2L. So 2L multiplied by, what is the force? Force I don't know, it is F3. But one thing which I know is definitely this is positive torque. Because the door is giving negative torque. Now what about this first hinge? What about first hinge? Adi torque ni vada? Ivadu. Endukala? Because it is present on the axis only, no? First hinge in this condition cannot give any torque because axis is present on the hinge itself. Okay? So therefore what I say, torque due to first hinge is how much, ma? Torque due to first hinge is 0. Okay? So this is torque due to second hinge. This is torque due to door. Net torque should be how much? 0. Why net torque is 0? Because door is not rotating. No? Door garran evana tiruta unda? Tiradam ledhu kada. It means net torque is 0. Clear now? Add all the torques. So torque due to door plus torque due to first hinge plus torque due to second hinge. Total should be how much, ma? Total should be 0. Because net torque is 0. So torque due to door, how much, ma? L by 2 into W. Torque due to first hinge, this is minus, no? Minus L by 2 into W. So torque due to second hinge, 2L into F3. Clear number? Torque due to third hinge, 0. Total it is equal to 0. Okay? So L get cancelled. So therefore 2 into F3 is equal to W by 2. Okay, ma? So therefore F3 value is how much? W by 4. Understood? So I got one more force. So therefore if I am studying about this second hinge, it is giving two forces. F by 2, F2 in upward direction and F3 in perpendicular direction. ఒక హింజ్ రెండు ఫోర్స్లు వేస్తుంది కదా. వన్ ఫోర్స్ టు బ్యాలెన్స్ ట్రాన్స్లేషనల్ మోషన్, వన్ ఫోర్స్ టు బ్యాలెన్స్ రొటేషనల్ మోషన్. అర్థమవుతుంది కదా? రెండు ఫోర్స్లు ఎందుకు వచ్చినాయి? వన్ ఫోర్స్ ఈజ్ ప్రెజెంట్ టు బ్యాలెన్స్ డోర్ కిందికి రాకుండా, ఇంకొక ఫోర్స్ డోర్ రొటేట్ అవ్వకుండా, అందుకని ఆ హింజులు వేస్తాం. అర్థమవుతుంది కదా? సో దేర్ ఫోర్ వాట్ ఈస్ ద టోటల్ ఫోర్స్ గివెన్ బై ఈచ్ హింజ్, మా? So one force F2 is in upward direction, one force F3 is in perpendicular direction. So what is the net force then? Net force is, I have to take parallelogram rule of addition, number net force. So F net is how much? It is equal to square root of F2 square plus F3 square. So square root of F2 value already we have calculated, no? W by 2. Okay, ma? And F3 value is how much? W by 4. So W by 2 whole square plus W by 4 whole square. So whatever answer you will get, that is the net force given by each hinge. ఒక్కొక్క hinge ఇంత force అని ఇస్తాం. Is it clear how we have calculated? Now that's it. Okay. So now you can calculate this one, no? So how much for this one? So square root of W square by 4 plus W square by 16. So take LCM as 16. So 4W square plus W square divided by 16. So root 5 W divided by 4. That's it. So that is the force given by each hinge. So he said that forces are equal, no? If second hinge is giving this much force, first hinge also will give same force. That's it. అర్థమవుతుందా ఏం చేస్తున్నాము? సో ట్రాన్స్లేషనల్ ఈక్విలిబ్రియంని బ్యాలెన్స్ చేయడానికి హింజ్ ఒక డైరెక్షన్లో ఫోర్స్ని ఇస్తుంది. ఓకేమా? రొటేషనల్ ఈక్విలిబ్రియం మెయింటైన్ చేయడానికి ఫోర్సు హింజ్ ఇంకొక డైరెక్షన్లో ఫోర్స్ని ఇస్తుంది. సో జస్ట్ యూ టేక్ ద వెక్టర్ సమ్ ఆఫ్ బోత్ ఆఫ్ దమ్. దట్ ఈస్ మై ఆన్సర్. ఓకే. You can take axis of rotation here also. I have selected this point. Understood, no? You can take anything to be your axis of rotation.